Welcome to the homework help for Unit 8, Lesson 2, Yard Work in Segments. We're going to get started with number 1 on the ready. So, for each set of numbers, find the mean, or average. Explain how the mean of the set compares to the values in the set. Okay, so we're calculating means, which means, we're calculating averages, which means we're going to add up all of the values that we have and then divide by the number of values. Or, in other words, and we'll put this in red, right? Our mean is equal to the sum divided by n, the number, right? So for this first one, we're going to have 6 plus 12 plus 10 plus 8. All right, 6 plus 12 plus 10 plus 8. If we add these all together, well, let's see, 6 plus 12 is 18, plus 10 is 28, plus another 8 is 36. So this divided by the total number, which is 4, right? That's the same as 36 divided by 4. So the mean is 9, right? 36 divided by 4 equals 9. So that's our answer to the first one. And then explain how it compares. Well, it's right in between 10 and 8, right? So our two middle numbers, so it's between our middle numbers, right? It's above 2 and below 2. It's above 2 and below 2, so it's sort of in the middle in that sense as well. So that works. Let's go to number 2. We'll switch to a purple for this one. We're going to do the same thing. We're going to add them together, so 2 plus 7 plus 12, plus 12, there we go, and divide by the number that there are, which is 3. All right, so that is going to be the same as 2 plus 7 plus 12. 2 plus 7 is 9. 9 plus 12 is 21. So we have 21 divided by 3, which equals, not 9. I looked up on the screen and saw 9 above. It's not 9, it is 7. All right, so we have 7 here, and then it matches, right? It happens to match the middle number, right? Match the middle number. There we go. And we'll switch back to green for this bottom one. Let's see, for number 3, negative 13 and 21. So we again set it up negative 13 plus 21 because we have to get the sum and divide by the total, which is 2. Right? Negative 13 plus 21 is positive 8. So 8 still divided by 2. So our mean or our average is 4, and it's just in between the two. It's in between the two numbers, and it is halfway in between the two numbers. Right, like the average of just two numbers is the halfway point between the two of them. It's the midpoint, it's the halfway point, it's just the average of two things, like midpoints. But we'll go on to midpoints in this next section, I think. Aha! Find the value that is exactly halfway between the two given values. Show your work. So we will write another red, right? So this is like halfway, we'll call it. Right? Halfway is going to be point number 1 plus point number 2 and then divide by 2. All right, that's going to be like the sort of idea. And we'll check these with common sense as well. So let's do in green. Oh, we just did one in green. Let's go purple. Back to purple. 5 and 13. So what's halfway between 5 and 13? Well, our equation says we're going to just do 5 plus 13 and then divide by 2. Right? And that's going to be 5 plus 13 is 18 divided by 2 is equal to 9. So this says that the answer should be 9. But maybe we're not confident that it's 9, so let's check. Like if we had a number line here, right, and we have 5 here 6, 7, 8, 9, 10, 11, 12, 13, right? And 13's here, right? And these are our 2 points. Let's make this a little bit bigger for 1 second. So I can put points here. Oh, wrong button. Right, and we have, right, 1 point here and 1 point here. Oh, I missed on the 13. Hang on. There we go. So those are our 2 points. And then if we wanted to check, right, what is our halfway point? We could take steps one at a time. So maybe we go, right, 1 step here and 1 step here. Right? We've now taken 1 step. Right? 2 steps. Here's a 3rd step. And now finally, 4th step. All right, so 4 steps would be, right, this would be 5, 6, 7, 8, 9, right? This was our conversion point, right? And then 10, 11, 12, and then 13. So sort of our common sense approach, where we're going to approach from both sides and see where halfway is, right? We also get 9. So we can use the common sense to check, but we also know that our halfway point is going to be add the 2 points together, divide by 2, or the 2 values together and divide by 2. So let's move on to the top of the next page. All right, so we're doing more of the same. We're calculating what is halfway between. So let's rewrite our little, right, our hint, right? Halfway is going to be, right, 0.1 plus 0.2 divided by 2, right? That's going to be our halfway point. All right, we'll do this in green. So negative 34 plus negative 22 divided by 2. Well, negative 34 plus negative 22 is negative 56. Negative 56, right? Which divided by 2 is negative 28. All right, and to check, right, so that's what we think it is. And how far is it from negative 28 to negative 34, right? So if our little check is negative 28, to get to negative 34, how far would we have to go? I think that's minus 6. And to get to negative 22, we'd have to go plus 6. So it's the same distance to either one, so that is halfway, right? That works. And then we'll switch back to our purple for the last one. Negative 45 and 3. So our first step is negative 45 plus 3. Let's add them together. And we're going to divide by 2. So adding them together, negative 45 plus 3 is negative 42. Divide by 2. Right, that's just negative 21. Right, and negative 21 is, it looks like 24 away. Right, so if we have negative 21 here, right, we'd have to go 24 in this direction, 24 in the negative direction to get to negative 45. Oh, that's not right. We'd have to go 24 in the negative direction to reach negative 45, and we'd have to go 24 in the positive direction to reach positive 3. So that works as well. So that works as well. So let's move on to our set. All right, we're on 13. Find the coordinates of the midpoint of each line segment provided. If multiple line segments are given, then give the midpoints of all segments. All right, so finding midpoints of segments, and if there are multiple line segments, find all the midpoints. Okay, that's fine. We can do that. So we now look, we have our segment. It looks like these points are, and we're going to label them here. Looks like our points are 1 comma, that's 1 comma 6, right? And our second point is 9 comma 2. 9 comma 2. So those are our 2 points. So the way that we find a midpoint of a line segment is just by finding the midpoint of the x's and then the midpoint of the y's, or sort of like halfway between the two x values, halfway between the two y values. So what we're going to do is split it up and do the x's and the y's separately. So let's do the x's over here and the y's over here, and we're going to split it down the middle. All right, so our x's, if we just add the x's together, right, that's going to be 1 plus 9 divided by 2, which is equal to 10 divided by 2. So our x, right, our x midpoint, or our x, right, the middle of the x's, right, so is going to be 5, right? Our x's, the middle should be 5. So on the x's, right, we know that the midpoint of the x's should be on this dashed line going upwards. And let's make sure for the y's, right, so it should be there, right where we just circled. But let's not assume that's going to work. Let's also check the y's. And let's see, for the y's, we have 6 and 2. So we have 6 plus 2 divided by 2, right? So this is 6 plus 2 is 8. 8 divided by 2 is equal to 4. So we get y equals 4, and that should be here. Yep, so that's our point. All right, so our midpoint is going to be x of 5 and y of 4. So 5 comma 4 is our midpoint. There we go. We have it labeled there, but we'll also put it here so it's just clear to see. 5 comma 4. There we go, that's our midpoint. We keep going down. Okay, that's the bottom of this page, so we're going to go up to question 15. All right, question 15. It looks like we have 3 different segments now, so this will be a little bit tricky. We're going to have to keep track of a lot here. We're going to do each segment in a different color. So I'm going to color coordinate the segments first. Or sorry, not color coordinate, color code. So this first segment, right, is going to be green. All right, this second segment is going to be a purple. We'll go with a lighter purple, that's fine. And our last segment we can keep as black, that'll be fine. So first segment being green, right? If it's a vertical line, then what do we know that, right? We know that our points, and we'll do our points in, we'll do them in a blue, that's fine. So this point up top is, let's see, 1 comma, that's 5, so 6, 7, 8, 1 comma 8 is the point up top. This point over here, oh sorry, that's not 5, or sorry, or rather that's not 1, and it's not, I was totally misreading this. Hang on, neither one of those is correct. Sorry, I was misreading this completely. Our origin, which we're gonna just sort of put bolder a little bit, our origin is here, which I made a mistake. Did not realize that. Okay, that's the origin. So let's go back to labeling points. This should be 6 comma 3. This top point should be 6 comma 3. The bottom point, right, the bottom left should be 6 comma negative 4. And the bottom right should be 10 comma negative 4. There we go, 10 comma negative 4. So those should be our 3 points. There we go. Now we will go back. So between 6, 3, and 6, negative 4. Well, we know that the x value, right, we're going to do this in green, right? So in the green, this is, right, our vertical, the vertical midpoint, right, our vertical line midpoint, it's from 6, 3 to 6, negative 4, which means the x value has to be 6, right? Because somewhere that's halfway between 2 points that are stacked vertically, right? It must be on this line. So the x must be, right? It must be on this line here, right? Which means that the x value has to be 6, right? So x is going to be 6, and we just have to figure out what the y is going to be. So for our y, right, we're going to have 3 plus negative 4 divided by 2. 3 plus negative 4 divided by 2. So 3 plus negative 4 is negative 1, right? So, oops, sorry. I'm rewriting the same thing, my mistake. So 3 plus negative 4 is just negative 1. We're going to write it here. Negative 1 divided by 2. And we can't actually simplify that at all, so we're just going to leave it just like that. So our y value is going to be at negative 1/2. So let's make this a little bit bigger. Let's go all the way to a 3, that'll work. So at negative 1/2 should be right around here. Oh. All right, and that point, that midpoint, has the coordinates 6, comma, oh, I did not like that one. Let's try that again. Try that again. 6, comma, negative 1/2. All right, so that's the midpoint of that line. Let's do the black line next because it's horizontal, so we can use the same sort of logic to say that if the y value is negative 4 on one end and it's negative 4 on the other end, then halfway between the two, the y value must be negative 4 once again. So this is on the horizontal, right? Our y is always, don't like that one. Our y is equal to negative 4, and the x is going to be 6 plus 10 divided by 2, right? It's got to be our first point plus our second point divided by 2. So the first x is 6, the second x is 10 divided by 2, right? So that 6 plus 10 divided by 2 is 16 divided by 2, which equals 8. So it looks like it should be negative 4 comma 8. And if we zoom in, let's make this 3 really quick. If we zoom in right here, oh, not quite, didn't quite get it. Right there, that point that we just bolded, and we're going to go label now, right? But that point there should be the point 8 comma negative 4, and indeed it is, right? So 8 comma negative 4, right? That's our black point right there. There we go. And now finally, we're on to the purple. We're doing it a little bit lighter purple than normal, but that's okay. And we actually have to keep track of x's and y's here, so we're going to make a little bit more space. We'll do, this is our diagonal. This is our diagonal line, is in purple. We're going to do the x's and the y's separately. So the x's for our purple line are 6 and 10, right? So the x's are 6 plus 10 divided by 2. We just did that down below. We know that that is 16 divided by 2, so that's 8. So 8. And for our y's, we know that it is going to be, for our y's, it's going to be positive 3 and negative 4. So positive 3 plus negative 4 divided by 2, which is negative 1 divided by 2. And we can't simplify anymore, right? Because positive 3 plus negative 4 is negative 1 divided by 2 is just negative 1/2. So we go over to add our midpoint at 8 comma negative 1/2. 8 comma negative 1/2 seems to be right here. It looks like I was off by just a bit, so let's try this again. One more time. There we go. And now we're going to label it. The midpoint there is 8 comma negative 1/2. 8 comma negative 1/2. All right, and those are the 3 midpoints for the 3 line segments in that in this shape, right, or on this graph. Right, let's keep going. 17. Here we go. A line segment between 2, 3 and 10, 15. All right, so we can't actually see on this one. We can't actually see it graphed out anywhere. All we have are these numbers. So we're gonna follow our same procedure where we keep the x's and y's separate. All right, so let's do the x's over here. X is over here, right? Y is over here. And so if our x's now are 2 and 10, so we're going to do 2 plus 10 divided by 2, right? 2 plus 10 is 12, so 12 divided by 2. And 12 divided by 2, right? 12 divided by 2 equals 6. So our x midpoint is 6. And now for our y's up here, right? Our y's are 3 and 15. 3 and 15. 3 plus 15 divided by 2. Well, 3 plus 15 is 18. So 18 divided by 2. And we know how to solve that. 18 divided by 2 is equal to 9. So we have 6 and 9. So our line segment has the midpoint, right? Midpoint of 6 comma 9. All right, and we are done with number 17. Let's go on to the next one. All right, number 19. This has its own question, so we're not just going to do midpoint calculations. Here we go. If a line is drawn parallel to BC and through the point A, at what coordinate will the intersection of this parallel line be with DC? Okay, so first let's just draw a sketch here, just to make sure. So if we draw a line, it's going to be a line parallel to BC, which means it has the same slope as BC, and through the point A. So it has to be parallel to this. Let's try that one again. It has to be parallel to this and go through this point A. So it's going to be something like this, I would guess. That looks like it's diverging slightly. Let's go a little bit. When do we think that's? I feel like it's probably like there. That looks pretty good. That looks like it's that looks like it's parallel. But let's check. Let's check real quick. So there are a couple of different ways of approaching this problem. We could do intersections. We could do proportions. We could solve for a whole lot of stuff. But we're not going to worry about that right now. We can do proportions. So we know that it's parallel. So what does parallel mean? Well, it means that we can find the slope of BC. All right, so the slope of BC, right? And the slope we're actually going to write up top, right, in red, right? slope equals the change in y divided by the change in x. All right, so the slope of BC is the change in y divided by the change in x. So from B to C, right, let's label some points here. We have a point 0, or sorry, if we go, it's -2, sorry, it's because it's 2 to the left. So point B is -2, and then how high is it? 1, 2, 3, 4. -2 comma 4 is point B, and point C is going to be 7 to the right. So 7 comma, and it looks like it's 2 below, so 7 comma -2. All right, so that's our point C. So the slope of BC is the change in y over the change in x. So the change in y is from 4 to -2, right? From 4 to -2, so 4 minus -2 divided by the change in x, which is -2 minus 7, -2 minus 7. So 4 minus -2 is 6, and -2 minus 7, -2 minus 7, that should be -9. So 6 divided by -9, we can rewrite this because 6 and 9 are both divisible by 3, right? So we can change this so we can sort of divide the top and the bottom by 3, right? Divide by 3, divide by 3. And we can say that this is actually 2 and 3, and we can pull the negative sign out in front. So -2/3, right? The slope, oh, I actually don't want to circle that because that's not the final answer. That's just the slope of BC, right? So the slope that we're looking for is -2/3. Now, if we go -2/3, right, if we're following the same pattern of going -2/3, -2/3, -2/3, right, we could follow this pattern where we go down to over 3, right? From point A, we could go down to, oop, I'm moving the whole thing. Yeah. From A, we could follow the same slope, right? Where this is down 2 over 3, right? And this is down 2 over 3, down to, oh, missed it again, down 2 over 3. So we could get to, oh, that looks like a 5, not a 3. Hang on, 3, there we go. And that would get us to this point here. So we drew something that looked parallel, and we guessed that it would probably be around there. Then we did it using slope, and we say it's going to be around there. There's one more way that we can do this, and it also uses this sort of like 2/3 approach. And we'll talk about it. I mean, we'll introduce it because there's a bunch of different ways to do it. So there's using the slope approach, which would be, what would it find this point as being? This would be the point, this is the point -2, right? So this point is, oh, what's the x value? 4. So this point is 4 comma -2. That's going to be the intersection point, 4 comma -2. Now the question is, can we get there another way? And the answer is yes. We could notice that A is on the line of, it's somewhere between D and B. And we have to find a point that's somewhere between D and C. How far, and this is looking at like ratios or proportions. So how far is it from, like where does A fall on the line between D and B? Is it exactly halfway? Is it 90% of the way to one side? Like what's the relationship there? And the answer is, well, from D to A, you know what, we'll change colors for this one. From D to A is 4, and then from A to B is 2. Which means the 2/3 of the way, right, from D all the way to B, right, 2/3 of the way there, we find A, right? So 2/3 of D to B is A, which means that if the line is parallel with BC, right, if A to some other point is parallel, right, it's going to have that same relationship, then we could also say that 2/3, we're going to go down below, right, 2/3, ooh, 2/3 of the way from D to C, right, is the intersection. Right, so how far is it from D to C? It looks like it is 9 total, right? D all the way to C is 9. 2/3 of 9 is 6. So the intersection is 6 from D. And if we go 6 away from D, right, 1, 2, 3, 4, 5, 6, we end up at that same point once again. So there are a bunch of different ways. There's the eyeballing it, there's graphing, there's calculating an intersection, there's using slope, there's there's using these proportions. But what's important is all of the ways that we can approach it will get to the same answer. So I'd say probably the green, the step we did first is probably the most intuitive, right? Because it says parallel, right? And I will underline that in green. Right? Because it says parallel, that does sort of raise alarm bells. Parallel means same slope. So using the slope seems the most intuitive. And if you wanted to go about this a different way, you could also do that. So let's move on. Question 20, question 21, we're going to skip for right now. Question 22. All right, here we go. If a line is drawn parallel to BD and through the point G. All right, parallel to BD through the point G. We know that it's going to be somewhere, right? Somewhere over here. That's where the intersection is going to be. But we don't know where. And this time I'm not actually going to draw something, right? Cutting it in half. Like, I'm not going to draw the parallel line because I think that gave us sort of an unfair advantage, and I don't want that. I want to find it using the numbers instead of using kind of what it looks like. I'm not going to draw the parallel line. We're not going to do it this time. We'll draw it at the end. So if a line is drawn parallel to BD, well, let's first figure out our slope. Let's figure out our slope of BD. Slope. What is our slope of BD? And remember, slope equals the change in y divided by the change in x. All right, so slope of BD. Well, point D appears to be, this is our origin, right? Let's make sure we have our origin correct. Right, this is our origin. So from there, it looks like we're going, D is at -5, 4, and point B is at 5, -1. 5, -1. So those are our points. So the slope of BD is going to be the change in y. So let's go with, right? Oh, that's not what I wrote, but that's okay. Change in y from B to D is going to be 4 minus -1 which is just 4 plus 1, so that's going to be 5. And our change in x is going to be, once again, using the left point, so negative 5 first. Negative 5 minus 5. Negative 5 minus 5 is negative 10. All right, so change in y divided by change in x. So our slope is 5 divided by negative 10, which is the same as negative 1/2, right? Because 5 over 10 is 1 over 2, right? It's the same, it's just half, and then there's a negative sign. So negative 1/2. So the slope of BD equals, right, negative 1/2. All right. So now from point G, right, use the slope of negative 1/2, right, from here. So we're going to go down 1 over 2. Then we're going to go down 1 and over 2. And we have hit the point, right? It's going to be this point right here. And what is that point? Well, it has the same x value as point B. So it's going to be 5 comma something. And it looks like it's 5 comma positive 2. Oop. 5 comma 2. Seems like that's our point. Now, we could also explore this using proportions, right? Let's do that real quick. We'll do this in blue again. So let's see proportions. So if we go from if we're going from C to D, right? From C to D, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So the whole way is 10, but G is only 4 away, right? But this is only 4. So, G is 4/10 from G is 4/10 of the way from C to D. So it's 4/10 from C. All right, so it's 4/10 of the whole way. And then let's look, which means that whatever our intersection, right? So we know that our intersection should be 4/10 of the way from C to B. So from C to D. All right, so if G is 4/10 of the way from C to D, which is the top horizontal line, then that means that the intersection should be 4/10 of the way from C to B, which is this vertical. So 4/10 of the way from C to B. Well, the whole way C to B, right? C to B is 5, right? From C to B is 5. 4/10 of that is 2, right? 4/10 times 5 equals 2, which means that the intersection should be 2 away from C, right? So this should be intersection 2 from C. And in fact, if we go over here and we go to C, right, 1, 2, right, that is our step. So we get the same answer that way as well, right? And our intersection is still 5 comma 2, right? So we do get the same answer both ways, which is good. Definitely more straightforward to go with the first route, but you can do it either way. All right. And finally, the goes. All right. solving proportions now. So we have to solve each proportion. So 5/8 is equal to something, some unknown value divided by 12. All right, well, there is a property called the means extremes property. And that property states, you know what, I kind of like this blue. We're going to keep working in this blue. That property states that if you have two fractions equal to each other, you can, it's called cross multiplying, right? That's the word that gets used a lot, but it's really the means extremes property. But you can sort of simplify. Means extremes property, right? And that's if A over B equals C over D, then A times D equals C times B. All right, it basically means that if you sort of circle along the x's, or circle the diagonals, you can multiply those things that are in circles together. You can multiply those together and have the equal sign between the two. Right? That's why it's called cross multiplying, because you're multiplying the top of one and the bottom of the other. But the way that we actually get there is by saying, and I'll show you these steps now. We will do it in blue, right? So our shortcut, we'll do our shortcut later on. But the first thing we might do is, okay, if we have 5/8 equals x over 12, maybe we multiply both sides by 8. So let's do that, right? If we multiply, because we can do that, right? We can always do the same thing to both sides of an equation. So multiply by 8, multiply by 8. All right, then what do we have left? 5/8 times 8, right? 5/8 times 8 is just 5. So 5 equals, and then if we have x over 12 times 8, we're going to have 8x divided by 12. Okay, now what if we multiply both sides by 12? Multiply by 12, multiply by 12. All right, now we're going to have 5 times 12, which is 60, equals 8x divided by 12 times 12 is just going to leave us with the 8x. So now we have 60 equals 8x. Now what do we have to do? I think we have to figure out what would go over the 12. So let's divide both sides by 8. Right? Divide by 8. And of course we could have done this a little bit more straightforward, but I'm trying to demonstrate a property here. So that's why we're doing it this way. And if we divide by 8, we have 60 over 8, and then these will cancel. So 60 divided by 8 equals x. So it's not that pretty, but we can definitely simplify. 60 divided by 8. Well, I know that 7/8 would be 56. So this is really 7 and 4/8, right? If we're dividing, if we take out 8s again and again and again, right? If we take out, right, 60 divided by 8 is just 7/8 plus another 4, right? So 7 and 4/8 equals x. 7 and 4/8 is just 7.5 or 7.5. So x equals, that was poorly done, 7.5. So solve each proportion, right? X would be 7.5. But you maybe saw, right? Maybe you saw this, is when we got to this part here, right? 60 equals 8x. when we had done our multiply by 8 and our multiply by 12, that's effectively what we did up here. So it's like a shortcut, right? We can use the means extremes property to get from here right down to there, right? Means extremes, right, is that shortcut. And if you wanted to just jump directly to this, right, I wanted to illustrate this property. But if you wanted to just do this the most efficient way possible, you would actually first not multiply both sides by 8. You would just multiply both sides by 12, and you'd end up with 60 divided by 8 equals x. Right? So the most direct way to do it would actually be, I'll change colors to green again. The most effective way would just be to move this 12 up to there to start, right? Multiply both sides by 12, you get rid of it there, it multiplies by the 5, and then you just have x by itself. That's isolating x. But this was a great chance to show the means extremes property, so that's why we did it that way. Anywho, I hope this was helpful. This is the end of